Okay, let's dive right into this. Welcome, 8th graders, to today's explainer. We're doing something a little different today. We aren't just looking at numbers and shapes on a page. We're actually going to explore how our math lesson on geometry intersects with a much, much greater divine purpose. We're talking about sacred geometry, dilations, and the divine standard. This explainer is specifically designed to stretch your mind mathematically while simultaneously rooting you deeply in spiritual truth. So get those notebooks ready, sharpen your pencils, and let's get started. Here's a quick roadmap of what we're covering today. First, the divine standard. Second, the transformations challenge. Third, a step-by-step math example. Fourth, your flag design challenge. And finally, education, morality, and peace.
All right, let's kick things off with Section 1, the divine standard, doing all things with excellence. Before we even touch a coordinate plane or talk about scale factors, we really need to establish the foundational big idea behind today's rigorous mathematical challenge. You know, it is so incredibly easy to see math as just an academic hurdle, right? Just another test to pass. But it's actually so much more than that. 1 Corinthians 10:31 tells us, "So whether you eat or drink or whatever you do, do it all for the glory of God." Now, you might be wondering, why does this matter in a math explainer? Well, because working through a tough mathematical challenge helps you apply what you've learned in totally new ways. Today, you're going to have the chance to be both highly creative and highly precise. Solving these problems with strict excellence isn't just about getting an A. It's a really wonderful, practical way to reflect diligence and glorify God using the incredible mental talents He's already given you. Moving right along to Section 2, the Transformations Challenge, where we'll be covering TEKS 8.9b through C and 8.1g. So the crucial point is, what are we actually trying to master today? By the end of this explainer, you're going to be able to do 3 exact things. First, you'll apply all dilation rules fluently. That means you won't just be guessing, you'll know exactly how to resize a shape mathematically. Second, you'll be able to explain the effects of transformation sequences, basically understanding what happens when we do more than one thing to a shape, like a dilation followed immediately by a reflection. And third, you'll be able to justify similarity and proportionality in real contexts. You're going to use hard numbers to prove exactly why 2 figures are mathematically similar. Now here's our biblical morality tip of the week, and it connects the coordinate plane directly to your actual life. Look at the balance here. In math, similar figures preserve their shape even when they get resized. A triangle might get twice as big, but its angles and proportions, they stay exactly the same. In life, God absolutely values consistency and faithfulness. We're called to grow, right? To change, to mature. But while doing all of that, we have to remain true to our God-given identity. When you face major transformations in your life, you are called to stay rooted in God's truth. Just like points on a graph remain in order and preserve their shape through a massive mathematical transformation. Okay, let's jump into Section 3, step-by-step math example, crunching the coordinates. It is time to put these principles into action. And here's a fun fact for you. These exact same transformation rules are what video game designers use to make characters move and grow on your screen. Pretty cool, right? So here's our 3-step procedure to see how it works. Step 1. We'll take an original shape and perform a dilation with a scale factor of 2. Step 2, we're going to take that new, larger shape and reflect it over the x-axis. And step 3, we'll compare the side ratios to prove whether or not our final shape is actually mathematically similar to our starting shape. Now, what's really interesting about this slide is we get to see the rules actively change the numbers. Let's walk through this together. Take a look at the first row. Our original point is 1, 2. For a dilation with a scale factor of 2, we just multiply both the x and the y coordinates by 2. So 1 times 2 is 2, and 2 times 2 is 4. Our brand new point is 2, 4. Now for the reflection over the x-axis. The rule here is that the x coordinate stays exactly the same, but the y coordinate becomes its opposite. So our 2, 4 becomes 2, negative 4. If we look at the second row, 3, 4 dilates to 6, 8 by multiplying by 2, and then reflects to 6, negative 8. And the final row, 5, 2 doubles to 10, 4, and then reflects across that x-axis to become 10, negative 4. This entire table is basically the perfect map of a transformation sequence. And this brilliantly illustrates the whole point of our math lesson today. If we take the distances between these new points and compare them to the distances between the original points, we're going to find that the side ratios remain absolutely constant. Because those side ratios are constant, the shape's identity is completely preserved. The figures are officially, mathematically, similar. This ties perfectly back to that earlier metaphor about consistency, right? The shape has transformed, it's moved around, it's grown a lot, but it hasn't lost its core identity. Which brings us nicely to Section 4, your flag design challenge. Time to apply your knowledge.
Let's move on and see how this all builds into your actual challenge set. This is where you get to combine your own creativity with serious mathematical rigor. First up, you'll design an original figure on a coordinate plane, and you're going to dilate it using a scale factor of 1.5. Second, you need to clearly write out the algebraic dilation rule you used. Third, take that newly dilated figure and apply a reflection to it, and hey, you can choose the axis. Fourth, use your math skills to justify whether your new shape is still similar to the original. And finally, I want you to write a brief explanation of how using coordinate rules actually helped simplify this entire process for you. This is where precision literally meets creativity.
And finally, Section 5, Education, Morality, and Peace, the HeroesmartAcademy philosophy.
As we look at the big picture today, I really want you to let this sink in. Education without morality will hurt. All of this math, all of this careful precision, it operates within a much larger framework. I mean, what is the point of being a mathematical genius, of knowing every coordinate rule in the book, if we continue to make bad moral choices that end up hurting ourselves and the people around us? True education simply has to be intertwined with a strong moral compass.
Because when we successfully combine our academic learning with solid spiritual grounding, there is an incredible promise waiting for us. Romans 8:6-7 promises absolute peace of mind to everyone who keeps his or her mind spiritual. This peace, it's the ultimate reward. It's what so many people experience when they engage with their education while keeping themselves firmly rooted in spiritual truth. You absolutely do not have to separate your brain from your faith. In fact, they work best when they operate right alongside each other.
So, what does this all mean for you? I want to leave you with this final provocative thought to carry with you. How will you apply today's lesson of consistency, both on the coordinate plane during your math challenge and in your daily life as you inevitably grow and transform? Remember to pursue excellence in absolutely everything you do. Maintain your God-given identity no matter how much you grow, and hold tight to that peace of mind. Get to work on those amazing flag designs, 8th graders, and I will see you in the next explainer.